In this episode, we work to create a new set of graphs that represent a new relationship. This time, our goal is to create a graph that relates the distance traveled by the point A to the height of the point as it travels counterclockwise around the square with a side length of 10 meters.
This would be distance, and then y is height, counterclockwise around the square with a side length, so it's 10 all around.
Mm-hmm. Well, each side is 10. So if we're calling this the midpoint, if it's starting at the midpoint, then this is 5, this is 5, and this is 10.
And then if you counterclockwise, one's total distance. Total distance is 40.
So it'd be 20. Because we're moving halfway.
Mm-hmm.
We're doing 5, 10, 5.
So it would go 20 up and 20 down, right? So because the distance is, like the distance would be 40, the distance would be 40, but the height goes 20, right? It goes
The height would only change 5 though. Because you go up 5. And so 5, you're traveling 5 meters and you're moving up 5 meters. Then you stay at a constant height for 10. And then you go to, and then we move down.
Oh, we're setting this as 0.
Yes,
Okay.
if that's okay.
Yeah, that's fine. So that one's 0. So height of 5. How do we do this?
So,
Distance travel is 5 first.
mhm.
So let's do.
Right here.
2 and 5s.
Yeah. Oh, this would be 15.
Well, not that. 5, 10, 15, 20, 25.
Mm-hmm. Perfect. So, from 0 to 5, that would be just going up half of this side length. You're moving 5 like this.
And then your height stays constant for 10.
Mm-hmm.
So another 5 and another 5. It's so ugly. And then we go down in height. And we move another 5. So go to right there. And then another 5, but we're below 0. So down into 5. And then straight across for 10. And then up for 5. Yay!
Wait, look.
For the square task, Zoe and Gisele broke the square into segments. The first segment went from the starting point, A, to the first corner. Similar to the elevator task, they noticed there was a direct relationship between height and distance. Next, the point travels over the top of the square, and the height does not change. Next, over the left side of the square, the point's height and distance are an inverse relationship. Then, on the bottom of the square, distance changes, but the height is constant. And finally, the point travels back to its starting point with a direct relationship between distance and height.